Hello again everybody, and welcome along to this tutorial on how to do error handling with Camunda. This will go through all sorts of things that will help you be able to deal with the various weird stuff that could occur while you're actually running your process or designing it. My name is Niall Deehan. I am an international consultant with Camunda. I'm joined as always with my faithful hawk, Ilbert Dogshoes. The hawk is not a requirement for this tutorial, but I've found it is very helpful. So, what are we going to do this time around? Well, first of all, you need to maybe have some idea about Java, in the sense that you should have maybe have some idea of how the API works or how to call a Java class, for instance. Some understanding of what REST is, how to make a REST call, that sort of thing. Be a good idea to understand the basics of Camunda and understanding the basics of BPMN as well. What we'll actually be learning is how to actually handle predictable errors using symbols that exist in BPMN, handling potential errors in design time. So this is things that may occur during your process, but you can actually plan for them before you deploy. Finding the cause of errors in runtime and also fixing those errors, because once an error does happen in runtime, you don't want to have to just destroy everything and start again. And also doing preemptive preparation to try and acknowledge that some things could happen and then know how to prepare for them. The two types of errors that you might be interested in understanding are, first of all, business errors. Generally handled by something like this, like a BPMN symbols. Here's an example where if we do something, a BPMN symbol called the error boundary event here can actually catch those errors and the process could continue normally. So these would not be technical errors, but instead a business error, something that has happened that we can that doesn't require any external intervention, but the process can continue. The other type of error is actually things that we can assume may happen for technical reasons. Here we have a properties panel here on the right, and this shows that we have created a transaction boundary, which I'll talk more about later on, and we also have a retry cycle. This is a sort of a technical error, saying stuff like, we will attempt this from a technical perspective, and if there's a technical failure, we can retry a certain amount of times. Okay, so let's get started. We're going to start off with a project that I've actually already created. So this can be cloned and installed in your own IDE locally before we begin. So just grab this little guy here and open up, import as a Maven project, and then open up your IDE. If you've done that, then you should see something like this. So here is Eclipse, and we have here our error handling project. It has a whole bunch of Java classes, and it has some BPMN models. I'm going to start by opening the ber.bpmn model. Okay, and it looks like this. Okay, so the model we're actually going to be dealing with or handling the errors of are a model in which we need a new airport. We hire a company to build it. We then design the airport. We call a sub-process to construct the airport. We then announce the opening and we wait for a certain amount of time until the opening happens and then the process ends. So it seems pretty straightforward, but this is actually a process in which people in Berlin may be familiar with, is actually prone to error quite frequently, and we're going to deal with the various errors that may occur. Okay, so let's begin by actually running this. So I've built this project already. Here I've just used Maven to construct my WAR file here, and I've then put that as part of my deployments in my Wildfly distribution of Camunda. If this is new stuff to you, then I would suggest go and check out the first tutorial video about how to deploy processes and how to set up Camunda. Meanwhile, my Camunda instance is running. It's looking right here, and I have my two models. I have BER, which looks like this. Okay, so now I'm just going to check out what happens if I start this instance. I'm going to start it via the REST API. So I have Postman right here, and I'm going to use Camunda's REST API to say, okay, the process is my server is localhost 8080, engine REST is the endpoint, and I want to start my BER process. It needs a few different variables. It needs airport code, it needs budget, and it needs an opening date as well as a business key. So what I'm going to do is I'm going to send this in with a let's say TXL. There's an airport I know very well, and I'm going to send this and see what happens. Okay, so I got back at 200 OK, and we can also see that this process started, and we can actually take a look at Cockpit and just refresh this and see that we ran through this, constructed the airport and built it. But there is of course a problem with this, which is TXL is the code for Tegel Airport in North Berlin, and this is very much already constructed. So the very first thing I want to do is I want to deal with the fact that during airport design we could figure out that actually we don't need to construct this airport. It's perfectly reasonable, and then we're actually going to basically not have to do this construction part and route our process differently. It's the easiest way to change the process, but it's also important to know that this is the most frequent way you will deal with potential errors, meaning that if this produces some variable, we then want to route our process based on that. And for that, I'm going to take a look at the Java class that's actually running here. So in our process, if we look back in here, we should see that there is our design airport. If we open the properties panel, you can see that we are basically design airport delegate is running some code. So I'm going to go in and take a look at what that's doing. And design airport delegate is right here. Okay, so this essentially is getting the airport code. It also has a variable here locally called airport needs construction. Okay, and then it basically checks what the airport code is. So for instance, if the airport is BER, that's Berlin Brandenburg, it needs all the help it can get, so that's the printout, and we do need to construct it. If it's TXL, that's Tegel Airport, it's basically falling apart, but that's the way we like it. We also have THF, which is Tempelhof. Tempelhof is essentially a park now. It's a lovely place to fly a kite. We should probably leave it that way, so no construction needed there. And Schönefeld Airport is SXF, and it feels like half airport, half minimum security prison. And we also have, of course, the final thing where it doesn't match at all. And in the end, we do set a variable back, which is called airport needs construction, which is exactly what we need. So what we do need is this variable is going to determine whether we're going to go ahead and actually build this. So to do that, I'm going to take the name of this variable, go back to my process. I'm going to make a little bit of space here, and I'm basically going to add an XOR gateway. Okay, there we go. And this is going to be construction required, and we have a yes and a no. Okay, and now we just need to add those conditions. So if I select this, I should be able to select expression, then hash, open curly bracket, airport needs construction, and then the other one here will say expression not. Okay, so that way we actually will stop doing this project if we don't need to. Okay, so let's see what happens if we run this. So to see this run, I of course need to go to Eclipse and actually build it and deploy it. So I'm going to do that by going to my project, right click, run as, Maven install. This is then going to build a WAR file containing the changes I've made and the Java classes and the BPMN models. Already we have our project built, so now I need to go down and I need to grab this WAR file which just got created. I'm going to copy that and once again go to my deployments folder. I'm just going to replace the one that's there. So what that'll do is it will actually get picked up by Wildfly. It'll deploy the new version, and if I go into Cockpit here, we should be able to see that we have our BER file. Great. And we now have version 2, which is right here, which has our change. So let's start this and see what happens. So if we start this and it has TXL, we should then end the process. So let's just run that. Okay, great stuff. And I know this is ended already because I got a response here saying it actually ended. And let's just take a look at the history to make sure that this actually happened. There we go, perfect. So now let's try it with BER. So let's go up here and change the code to BER, and this should get some construction done. Okay, there we go, great stuff. And this is not ended, which means that if I refresh this page, we should then see that we have a second instance that it's gone across. Okay, and it's waiting right there. But of course, we haven't dealt with some important problems. For instance, what if we are have got a problem with somebody deciding that they want to do something like add in their own airport code? Let's say they want to put in DUB. So any guesses to what might happen? Well, you can fast forward the video or press play. Let's find out. Click start and we get an internal server error. So this is the first actual error that we've come across in terms of technical errors. We have sent in this information. The server has actually started. What actually happened was the thread that started this, that was sent by Postman, went into the engine. It did this. It ran this. It then tried to run this, probably successfully, and then failed at some point and then rolled back. And that error then appeared from the initializing thread, which is the thread that starts in Postman, which is why the error shows up here. An important thing that's happening here, which is very irritating, is the error is not showing up here at all. Okay, now this isn't strictly a technical error as well, because we can actually deal with this using BPMN. So let's take a look at our process to see how we can improve it to deal with this issue of people sending in some random text that's going to cause a problem later on. So let's head back to our model. In our model, we have this guy here. And if we take a look at the code once more, we have here that we return, if we don't know what the airport code is, we return a null. And if we take a look, our log will show us later on that this will actually then throw an error. So the first thing to do is, and this is always important, is we want to be able to see that error in the right place, meaning that right now, if I'm an admin, I do not know this error has happened unless I am very strictly looking at the logs. So what you can do is you can say, okay, well, if this service or system or somebody starts a process, we want to make sure that we catch any errors that occur in Cockpit. Now, this seems like a very, very complicated thing to want to do, but it's all about understanding when the thread needs to commit. So for instance, this error was returned here because the thread was initialized by this external service. But if we say, okay, let's go to our process and let's actually select this and say asynchronous before, tick that box. What this does is it allows us to say, okay, if the process gets this far, then you can commit and return to say, okay, this has been successful. Well done you, congratulations. So, and then what will happen is the engine itself will pick up that thread then in its own thread and then move the process forward. If an error subsequently occurs, the engine itself will catch it. And we're going to take a look at what that looks like right now. Same as before, I just need to go back to Eclipse and build this again. So let's just do that. Another successful build, so let's copy the WAR file, go to the deployments folder and same again, just drop it in there. Okay, now we can watch as that thing gets picked up and deployed, and we should be able to take a look at, this only has 2 versions right now, but if we deploy a third, that means we should have version 3, and here it is. So now we have version 3, so how does that change? What happened here? So as before, I sent this call in, which calls the latest version of the process. And what we got back was this conditional expression null thing. So let's see what happens this time. Okay, so loading, good stuff. Oh, hey, look, 200 okay, so that's fantastic. The important thing to know is that this is only successful from the perspective of being able to start the process. So the error has never been fixed. If we refresh this page, we should see exactly what's going on, which is we should have one instance started, but that instance has a big red thing on it, and this means that it has an incident. If we were on the front page here, we would see that this is the open incidents. We could select it, and then we could go into the specific instance. Okay, so once we're here, we can basically take a look at what probably went wrong. So the thing that went wrong, if we take a look at the incident, we now actually get, first of all, we have the state, which is maintained. We have the incident, which we can open up and take a look at the stack trace. There it is. And we also have the ability to say, okay, this external system that started this process, they have not necessarily failed. They gave us the, this doesn't say Berlin airport code, this just says airport code. So as far as they're concerned, they gave us the right information, and we're not throwing an error back at them. Instead, we are holding the error here in order for us to be able to find out what's going on. So the next issue is find out what this error is all about. So here it's saying that a condition returns null. And this makes sense because if you take a look at our code, we have a value that will be null, which is airport needs construction. So where's the error really occurring? Well, it occurs basically here or here, where we're trying to evaluate an expression in which the actual value, the variable in there, is null. So how do we solve this little problem? Well, at this point, we can kind of take a step back and think, this is, I would consider, a business error. Somebody has given us some information, and we can't proceed because it's not one of the codes we know about. So what are we going to do? Instead of returning a null, I am going to do something really simple. I'm going to say throw new BPMN error. Okay, so what I should do is, there we go, it should let me throw a wrong code error. Now what does that mean? It means that it'll return to the engine to say, okay, the code is incorrect and we want to deal with it in a different way. So if this were to happen, we basically don't want to continue. Instead, we want this code to be thrown to our model, and then our model orchestrate a different path. So to do that, I'm going to drag and drop a symbol here, and this is the error boundary event. Okay, so this is going to say wrong code. So if it's the wrong code, we just don't know how to proceed. We just have no information, so we're going to just end the process. To make this event catch this line of code, we just need this key right here, this error code. And if I go here, I can basically say, okay, I've one here pre-made actually. So we can say, okay, if I enter in the name of the code here and the error code here, then it'll catch that error code. Okay. So that will end the process. So now let's actually make that work. Again, I will go here and I shall once more build my project and Maven install. Okay, another day, another successful build. So let's copy this for the penultimate time and let's pop it in there. And once more, we're going to replace the file that's there and hopefully get a new version of our process. So let's go here to our versions. Let's go to process, BER. We have version 4 here. So now if I were to start this process with DUB, I would send it. And we get no error back, which we want, but we also don't want an incident. We instead just want the process to end. So if we take a look at the history here, we should see the process started, it arrived here. It shows here that it was cancelled by the error and it went up here. Now, this of course brings me to how do you deal with runtime errors, because this error here has not gone away. Okay, so this error is still quite happily sitting here saying, what should I do? Luckily, and we have fixed this in the new version. So the obvious thing is we would like to move this to the new version. That's pretty straightforward. We click on migrate. It says link this one to here. So that's where we're going to move this token to the new version. And then we're going to just migrate everything. And great stuff, let's do that. Okay, so just step through that. And now we are going to take a look that we now have our error where we want it here. But of course, that still hasn't exactly solved our problem because we're still in a state of error. So the next step would be to try and, I'm going to do this manually, you can do it programmatically if you like. What we could do is we could essentially say, okay, I want to retry this step. So to do that, I'm going to pick up this token and drop it back on top of it. This is basically going to say cancel the current error step, and I want you to start this process before this. So let's see what happens in that case. Great stuff. So now we can see that the incident did happen, so that's not going to be forgotten about. But now you can see it actually runs perfectly and the incident is over. Okay, so just as a quick recap, what we've done here is we were able to fix an error in runtime by essentially fixing the process definition itself, redeploying it, migrating the errored instance and then retrying the instance again. There's a few different ways I could have retried it. That was a very manual way and it's a very visual way, but you can also do batch operations, do things like give errors, let's say a retry to make them do it themselves, but I thought it's more visual to show you exactly what happens. Okay, so what's next? Well, what's next is that we have a little sub-process here, and also with that comes a really common problem, which is our sub-process that we call needs to tell the parent process that something needs to be dealt with. So for instance, if we take a look at this sub-process, it is called, let's find a version that finished. Nope, let's try version 2. Great. So if I click in here, pick one of these, and I can see what happened when we call this sub-process is that we purchase some materials. We then we build a section of the airport. We spin around a few times until we've basically run out. There's no more to build, and then we finish things off. Okay. So there's a very important thing is what happens if after we need to purchase materials, we need to create some work to do for the parent process. Specifically, somebody up there can asynchronously take a look at the purchase to do an audit on it to make sure that these purchases are going okay. So that's what I want to achieve. What I want to achieve is that our parent process, which is this guy here, is able to deal with something that happens in this while the subprocess is working. So to go to our subprocess for a moment, what I'm going to do is I'm going to create an intermediate event, and this event is going to cause a escalation. Escalations are really important. They work a little bit like error events in that they propagate to the next scope. But the difference is that these can be thrown while the process is not impeded. It can still continue. So that means that we can say, let's say, needs audit or something, or needs approval. Okay, because a purchase has been made. And in the same way as we create an error, we click this little plus button up here and we basically say, okay, this is going to be approval needed is the error name, and then we're going to correlate on the error code, which I'm going to give the same thing. Okay, so how do we then have the parent process catch this? We basically go back here. Now we know we throw it. We are going to be waiting for this. And we, unlike this error event, which actually changed the direction of the process, we do not want to stop anything. We want to run in tandem with the subprocess and this parent process. To do that, we will create a boundary event, but this time we're creating a non-interrupting boundary event. Okay, so this would mean that we essentially have a boundary event that, if triggered, is going to go here to this user task, and it's then going to say check purchase. And for this particular thing, I just need to make sure that I have exactly the same correlation code. If I want, I can add a variable, but it's not required. And then it will get triggered and sent up here, and it shouldn't interrupt the path of our process. So even if we have to purchase a bunch of stuff, we will still continue the process. So that's all I need to do. I give this guy here a code. I gave this guy here a code, and now I just need to go back to my process and for the final time just rebuild my process. So for the final time, sing along if you know the words, copy your WAR file, pop it into the deployments folder, and replace the existing file. Okay, so then we can take a look at our process. So we should be able to see that BER, and there it is. So now we should be able to test all of our previous attempts to start this process. The first one is we're going to start a process that I expect will not be part of the airport codes that we know about. So let's go here and let's add DUB, okay, and send that. Okay, no error here, which is really good news. And if I refresh this, we should then see that this was an error. Okay, great stuff. Next up, I want to see what happens if we do have the airport code, but we know it doesn't need construction. Okay, so that would be TXL. Okay, again, great. So let's refresh and see what happened there. Okay, great, it went down there. And then finally, let's build BER. We've been at it for a very long time, so this shouldn't be too hard. BER, let's send. Okay, once more a success. And we can see that we reached the airport construction. It's still running because we need to check these lovely purchases. And we can then take a look that we can actually verify this was triggered 10 times. We now have 10 instances here. We're also waiting for the opening date because these purchases still need to be checked despite the fact we could actually still open the airport. I can click on this little button here to show that beyond, except for the first time this was triggered, it should have sent a request 10 times, which it did. And now we have essentially done this very, very complex thing in a very, very easy way. Okay, so hopefully that has helped you guys understand how error processing works in Camunda and the various different means you can do. There's lots of other stuff. This is just a beginner guide, but please do let me know if there are any additional things you're interested in. Thanks again for watching and see you again soon. Bye bye.